Ladies and gentlemen, our next panel this afternoon is titled Leveraging the National Innovation Infrastructure in Support of U.S. Manufacturing. Please welcome our panelists. Dr. Curtis Carlson, Vice Chairman, Innovation, SRI International. Dr. Michael Kluse, Director, Pacific Northwest National Laboratory. Dr. Peter Littlewood, Director, Argonne National Laboratory. And Dr. W. Randolph Woodson, Chancellor, North Carolina State University. And please welcome our moderator once again, the Honorable David T. Danielson, Assistant Secretary for Energy Efficiency and Renewable Energy, U.S. Department of Energy.
All right, just like last year, I want to remind everyone who's still here and here until the end, we take attendance, and for those of you still here, when you apply for grants at DOE, you're given strong preference. Just wanted to remind everyone about that. I'm really excited about this panel. I think we're gonna take a little bit broader view on the topic that we have today. So let me just set it up, and then I really want to hear from this panel. We have a great panel, and excited to hear some of their thoughts. So, by my view, what I want to talk about in this panel, the big idea, the big opportunity. If you look at, a big part of our manufacturing situation, our clean energy situation, is that over the last few decades, our economic system has evolved in a way where we've evolved away from having a lot of long-term corporate R&D happening and a lot of large corporate R&D labs like Bell Labs and other labs like that, RCA labs, that were really driving the long-term innovation in this country for a long time and driving our long-term competitiveness. And so now we're in a new era, the last number of decades, where I think we just recently had a real kind of clean energy investment boom, especially in venture capital. I was part of that as a venture capitalist. But I think what's been realized is that venture capital model isn't really well set up to fund that early stage innovation. It's something that's capital intensive and takes a lot of time. And so what I see, the broad mandate of our panel today, we have an opportunity, I think, to really focus on innovation infrastructure as one key element of a new model we could develop. But basically, what's this new model? What are the elements of this new model that I think everyone on this panel and most people at the conference today, the summit today, we're all working on a piece of this elephant. We're trying to figure out how do we get these advanced manufacturing technologies, these clean energy technologies, these capital-intensive, innovation-intensive technologies that take a lot of time to invent, but they're incredibly important, and our model's not set up to do it. And so I think what we're finding is our institutions are all evolving to try to meet this new need, and we're trying a lot of things, but I think there's an opportunity for us, I think, in the next few years to kind of lock in a new model for how we're going to do this. And I think there are some elements, including what's the role of foundations and philanthropy in funding innovation in these spaces? What's the role of universities, and our national laboratories, moving from kind of any sort of ivory tower mode to more of an industry partner mode? Talking to industry, I hear a lot about open innovation, funding universities, working with the national labs. We've got major corporations for the first time trying to figure out how to work with multiple national labs, multiple universities. A lot of people are trying a lot of things. And what I'd like to do is talk, I think with a special focus around some of the shared infrastructure, which is another important model where, you can actually get access to world-class capabilities to demonstrate and scale technologies on an incremental basis. I think that's one puzzle piece here, an important one. But what I really want to do is address this topic with our panel for the next about 30 minutes and hope to get some insights and thoughts and hear about what's working, what's not working, to move us forward toward that model that is going to really drive sustained models for how we're going to scale these technologies going forward. I wanted to start with Kurt Carlson, Vice Chairman of Innovation at SRI International. SRI has been one of the most amazing, productive innovation houses, and they get a lot of things to market. And so, Kurt, what I'd like for you to just kind of give us some of your perspectives on this. Now that we're in this kind of new space, how you as an organization have worked to kind of bridge this gap that exists in our ability to get technologies from idea all the way to the marketplace in these capital-intensive, important, long-term innovation areas.
Well, the first thing is I think we owe a special thanks to John Rogers because he told us and showed us basically how to thrive in this world. We have to start by looking at the world we're in, which I call the global innovation economy, and it's characterized by a number of things, one of which is it's the best time for innovation in the history of the world. Every field right now is wide open. There are more billion-dollar opportunities than I've ever seen in my entire life. Every field is like that, whether it's healthcare or energy or manufacturing, every area. But it moves really fast. So all the technologies now are basically improving exponentially. Even the manufacturing technologies are basically becoming IT almost like in their nature and how they're going to be developed in the future. The car that we saw this afternoon was a perfect example of it's more IT than it is anything else. It's the manufacturing technology is going to allow that to happen. It's also the most competitive time. If you start a company anywhere in the world now, as soon as you put your website up, your competition knows you're doing it, and they're now competing with you. That's the only time in the world that's ever happened. So when you think about this world we're in, speed, and what John was talking about, becomes one of the critical elements. Speed, 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 if you want to capture your fair share of the opportunities. So that means that anything that slows you down, bureaucracy, government regulations, anything that slows you down is bad news. And the good news is America has more opportunities now, particularly with low energy costs, than any country in the world. But remember, we have the highest business taxes in the world now. When I go around the world, people make fun of us because that is so out of whack with the rest of the world. I always say, we have to thank Japan because they used to be number one, and now we're number one. The second is the regulatory environment is crazy in many parts of America. In California, where I live, all we want to do is redo our campus. It'll take us 3 years just to get permission. No manufacturing plant can stay in California with that kind of delay and uncertainty. We're talking about, I was talking with David in Whirlpool about product cycles of a year. If you can't build a new plant, you can't be there, right? We're doing things like this tax on medical devices, one of the golden areas for America, where we put a 2.3% tax on gross revenue. Now, you've been in the venture world. That is the worst thing you can do. You don't have positive cash flow at that point. Every dollar is critical to you. And if you're in a business like that, you're not going to get money for 7 to 10 years because it takes you that long to develop the product and get the approvals. You can't be in America in many medical devices. So I would say it's the best of time for America, but we have to wake up and realize, first off, that we're not as competitive as we need to be in America. We're not close to that. The second thing I think we have to admit is that America is broke, and everybody has stood up here and said, we want more money, more money, more money. We don't have more money. We're going to have less money. So there's only two things you can do if you're going to have less money. You can use technology to become more productive, or you can improve your human capital. And I visit national labs all over the world, and I believe that there's at least a factor of 2 in every laboratory I've been, whether it's the national labs around the world or the corporate labs. I'll end with one little story. We teach the fundamentals of innovation at SRI. We've had thousands of senior executives and leaders from national labs around the world come visit us, and we put them through this little workshop, and we asked them to come and work on their most important initiatives, the most important things they're doing. And we sign all the papers so they don't have to give us any proprietary information. We don't want that. And we put them through our workshop, and we give them a language to talk about innovation and a process to talk about innovation. And over the course of 3.5 days, they then decide, of all the projects they brought, which ones have any value for their company or the nation. What percentage do you think it is? Is it 80%? 50%? 30%? It's usually between 10 and 20%. We don't decide, they decide. That's what we see all over the world, even with great companies. They have no process for innovation. They have no good way to talk about it. So one of my points is, I think one of the untapped resources in America is the way we innovate, the way we work I think there's a factor of 2 there, and I think there's a factor of 2 in technology, so that America, and there's another factor of 2 if our government will clean up their taxes and regulations to move America forward.
Well, that factor of 2, our lab directors, I think on this panel last year, we launched the National Lab Impact Initiative at EERE with the stated goal of doubling the amount of successful, impactful engagement between our industry and our national laboratories. I will say, as I go out in our national laboratories, I find phenomenal success stories everywhere I go. But I believe that Mike and Peter and most of us would agree, we probably, if DOE could do a little better, labs could do a little better, we pull together, we could get twice as much out of this system. And so, Mike, I wanted to go to you first to get your thoughts on some of the ways that you and the lab at PNNL are working to try to take that level of engagement and industry relationship to that next level.
Yeah, great. Thanks, Dave. Just to build on the last comment about there is no money, absolutely no more money. That's absolutely true. And so what that demands is we have better alignment between the various components of our innovation ecosystem, the labs, the universities, and industry. And we're recognizing, certainly at PNNL these days, that partnerships are probably more important today than they ever were for a couple of reasons. One is, when you look at the kinds of problems, the scale of the problems that we're all trying to solve, they're too large for any one university, industry, laboratory to solve on their own. It really takes the best minds across all those sectors. Secondly, particularly in the energy space, when you think about the technologies that get developed at the laboratory, if they're going to make a difference, they've got to get out of the laboratory. They've got to get in the commercial sector, because the commercial sector owns the vast majority of the energy infrastructure, and they've got to work at scale. And frankly, I don't think the laboratories are all that good at working at scale. So we're really valuing partnerships in a way that we haven't in the past. And so I'm sure there's been a lot of talk today about taking advantage of the range of scientific user facilities that are at the national laboratories. But it goes both ways. Quite often there are assets in the industry that the laboratories can take advantage of. For example, we're doing work in geologic sequestration of CO2. And so we've been working with power plants in Oregon and a paper mill in Washington, taking advantage of the fact that they're there, they produce a certain kind of effluence, and we can actually build an experimental site on their location. So they have something to offer us, as well as the laboratories having these broad set of scientific user facilities that industry and the universities can use. So it does go both ways, and that quite often gets forgotten. The other thing is data partnerships. We're doing a lot of work through Dave's organization, through Pat Hoffman's organization, to modernize the grid of the future. And in the case of the grid modernization, we've got established partnerships that are data partnerships with the utilities to get the live phaser data into the laboratory in a research mode. Certainly we don't do any control there, but the whole idea is to have that real phaser data at our disposal, so as we try to develop new control algorithms, new control paradigms to make the grid more resilient, more secure, we're working on real data. So we're putting in place data partnerships as well as partnerships around individual facilities. And then there's the whole issue of having industry involved when we have a research prototype or a prototype in mind. We've got to have industry involved early on, so that we know that as we develop technology, there's a path to manufacturing. And again, we need the insight of industry. You can't just do that at the end and say, okay, now let's commercialize this, let's get it to industry. You've got to have industry involved very early on, and we're recognizing the value of that. And certainly, Peter and I are very much involved under the energy storage hub that Argonne leads. We have industry as an integral partner for just that reason. So partnerships are really important. It goes both ways, and we've got to get the infrastructure aligned if we're going to be successful and achieve those factors of 2 and 4 that were mentioned.
And Peter, one thing that someone said to me today is maybe one of the more obvious things that for some reason hadn't sunk into my thick head is, if you're trying to figure out how to do things better, why don't you look at the couple of things that you're really doing well and figure out what are their key features? I would say that our world-class human capital and physical infrastructure that we've had at Argonne National Lab, supported by DOE's Office of Science and EERE over decades, is one of those great success stories. You know, nearly every important material has come out of this. World record materials have come out of this. And now with a $120 million 5-year energy innovation hub on next generation beyond lithium-ion battery materials and batteries, it's kind of taking it to the next level. So I was wondering, Peter, if you could comment on, I feel like this is a great example where human capital and physical infrastructure has resulted in great industry interaction and industrial success. Maybe you can talk a little bit about that and what is it that's made that work, and some of the work that you're doing to try to even take it to the next level at Argonne.
Yeah, no, thank you very much. I mean, it's very interesting. I mean, just to remind everybody who doesn't know the labs, one of the things that the labs have is a lot of stuff. You know, anybody who goes to the lab say, wow, you know, I mean, you know, we have big machines, big instruments, big computers, and these have been provided as a partnership with DOE over many years. And often these big facilities are very well used, I find, by the scientific community. So the academic scientific community knows these very well. They're very strong partners with us. When it comes to the commercial community, then it's more challenging to get this to work. But you know, big companies know. So interestingly, you mentioned high-performance computing earlier. You know, we've been working for GE for several years, actually, at high-performance computing simulations of turbines with their goal of stopping having to prototype so much so that they can design to manufacture. And that's a 5 to 8 year partnership, which has actually, I think, delivered them a lot of value. It's also delivered the community a lot of value because they've been prepared to do this openly and to publish their results. So where we sometimes have challenges with these facilities is actually making use of small companies. Because as mentioned, small companies are in a hurry. But you can still do that. I think I'm challenged actually now by beating the speed of the crater. So I heard over lunch actually that you could do a 2-month crater at Oak Ridge, and I'm wondering if we can get one faster than that at Argonne. That might be a lab-to-lab competition.
I like that competition.
We
that
could
sounds
do that.
Good.
But interestingly, there was in fact something that was just a small business announcing in northern Illinois this week, a company called Argonne Semiconductors. They began as a user interaction with the Center for Nanoscale Materials at Argonne working on diamond. It's turned into an IP portfolio shared by this company in the lab. They just announced that they're acquiring a foreign company, bringing them to Gurnee, Illinois. Gurnee, Illinois, by the way, is famous for outlet malls and roller coaster rides. So it's a new thing in that part. And we're very proud to have those kind of interactions. And by the way, the plan is that we keep this going forward. Okay. I think this is a model that worked in this case because there was a brilliant scientist who had a vision for his company and wanted to take it and dragged the labs along behind it, and indeed turned up last week and said, can you do a crater in 2 weeks so we can get this going? I'm trying. But let me come to the battery story, which I think is interesting, and go back to history. And some of this is history of DOE, and I've acquired it by osmosis from my earliest. So Argonne began to do work on batteries in the 80s and 90s. It was funded by Basic Energy Sciences. Sometime after that had been going very, very well, BES looked at this and said, well, this work's been really successful. On the basis of this, we've decided to stop funding it. Luckily, there was an organization within DOE, which became ERE, that said, we can move this forward, we can take it forward, and we can work with you. And they helped us build a whole set of infrastructure at Argonne for testing battery materials, prototyping cells, working that through. And again, bringing in industrial collaborators, and they've been doing that for a very long time. And after a while, you begin to find you have a cluster in an industry which is very slow to develop, very difficult to move. But pushing that forward over a number of years has got us to a stage now where all of a sudden everybody is talking about storage. It is the technology which is the need to have. And because of government investment, we have a whole set of stuff there. Okay? The challenge for us now is to get it deployed rapidly, commercially, and that, I will say, is something that historically the labs have not been so good at doing. And I think the challenge for us is to be very flexible, to be very rapid, to find ways of getting rid of the boundaries that somehow we've created for all kinds of difficult reasons, and to look to our customer as being the market rather than our customer as being the federal government. Sorry, that was a long answer, but maybe.
No, it's great. I think there's an opportunity to change the culture a little bit, to make our laboratories more oriented around industry impact, for sure. I've been doing a National Lab Impact Initiative tour, where I've been visiting each and every one of our national labs and giving a keynote address to everyone about all the things that we're going to change together in our model to move us in a more impactful direction. And at one of the laboratories that will not be named, I had a lab director next to me, and we were just taking open questions from the audience. And that exact question of like, hey, if I'm successful and I get this technology out into the market, what am I going to do? And so I think that kind of a cultural, you got to create a culture where those kind of things are incentivized, right? And I think whether it's M37 you heard about, our LabCore program that we're rolling out, it's a lab mirror of iCore to really get our researchers to think more about the ultimate application, to talk to customers, or whether it's our small business vouchers program, our technologist in residence program. We're trying a whole bunch of new things to try to bridge the gap, to try to change the culture a little bit. One other thing we're doing this year is each and every one of our technology office directors, like Mark Johnson, Min Lee, who you just saw, I'm asking them to take 1% of their laboratory funds and invest it into tech-to-market kind of activities. And one of the magic bullets that I've seen is just simple shoulder rubbing, which just doesn't happen enough between industry and our researchers. And so things like industry days across the board, getting our researchers to actually fly out and visit factories. I think these are all going to make a really big difference. That moves us to you, Randy. I think really, I've noted it that we've really, as we moved away from this era where we had these a lot of long-term R&D coming out of the private sector, major corporate R&D labs, we've moved away from that. The university has become, the role has really evolved. And one observation that I had when I was a venture capitalist, and it was kind of during the first, that early clean energy boom, I was, around MIT at the time. We go to Stanford, and you'd go there, and it's like, all the greatest ideas and researchers were already pretty tied up with their venture capital relationships. And so I thought, hey, I'm going to go hustle. Most venture capitalists aren't willing to fly like 30 miles off either coast. So I'm going to go hustle. I'm going to go and visit, some of these Midwest universities. And what I found is there was tremendous innovation. There were brilliant innovators, but there was still kind of an ivory tower attitude that, a distrust of business, that if I do some applied work, I lose my credibility. So, Randy, I'd love to hear a little bit about your view on that evolving role of the university and some of the work that you guys have done at North Carolina State to move the university into this new era.
Well, thanks, Dave. I couldn't agree with you more. And when I think about what's going on at NC State, first of all, I'm very grateful for leaders 25 or 30 years ago that really identified an opportunity for a university to be very engaged with the private sector in the Triangle. And they created a campus for NC State where you rub elbows, just like you described. So our campus actually is the home of 64 company laboratories, side by side with our engineering faculty. Shared facilities, shared activity, bumping into each other every day. And when I think about what that's doing to change the culture, that interaction constantly with the private sector is a big part of our success. And frankly, I think it's a big part of why we've been selected with our partners to lead the wideband gap semiconductor NNMI. Thanks for that acronym, by the way. It's awesome.
I call it anemone sometimes. So.
But I think one of the challenges we face in the national labs and universities is that our inventors, our faculty, often think that their inventions are really valuable. And they certainly have the potential to be, but that value is not realized until it finds its way into the market. And one of the things that we have to do a better job of is partnering with the private sector to identify work early on, keep the barriers of entry very low. We have MOUs with many companies where there's no agreement on intellectual property up front. The agreement is we're going to release it to you. We're going to hope that it's successful. And when it is, we'll come back and talk to you. And Cree is a great example of that. You've heard from Cree on the video this morning. That's a company that came out of 4 PhD students at NC State. No money to license intellectual property. The university takes an equity position in the company. It goes public. The university does well with the equity position, reinvest that money in future companies. And that's what we're trying to do, to be more innovative in the way we move technology out of the laboratories and into the market. The other key, I think, for us, related to that, is we're a university built on engineering and technology. So it's when you're surrounded by a group of engineers, many of which have spent time in the private sector, I think people think a bit differently about moving technology into the market.
Yeah, absolutely. Kurt, you know, you've written on innovation, you've thought a lot about innovation, you live innovation, SRI. You know, you made some, I think, some very compelling, you know, broad comments, but if you dive in on the SRI model itself, what do you think it has what are elements of it that can inform us as we try to think more strategically, more comprehensively about arranging our existing innovation infrastructure in a way that we can get more successful commercial outcomes from our R&D dollars we're investing?
So you just said the key word, comprehensive. There have been a lot of things that have been mentioned at this conference that were all individually good things to do, but the truth is they won't move the dial because they're one pieces of a total system. So let me use venture capitalists in Silicon Valley as an example. About 60 or 70% of venture capitalists in the best ecosystem in the world, with the best technologists, with the best partners, with the best financial folks, fail every year. A small percentage, 10, 20, 30%, make money every year. What's the difference between those top ones and those ones? The big difference is the ones on the top stick to the fundamentals of innovation, all of the fundamentals of innovation. So if you want to be success in a world that's this competitive with a technology that is as hard as energy, you really have to stick to them or you have almost no chance of systematic success. You can be episodically successful, of course, because people do remarkable things. So if you're a venture capitalist, you want a big, important, growing market need. You want to have a compelling value proposition for the product. You need to have a compelling, defensible business model. Many energy initiatives that have spun out of the Department of Energy have had no business model at all. As you know, we've talked about this. We'll get to it. We'll figure it out when we get there, right? And energy is hard because it's political. It's got big market risks associated with it. It's not a venture deal because the capital is proportional to the size of the business. So it's got lots of things that make it especially hard. But you need a compelling business model. You need to have the best team, not a good team, the best team. If you don't have the best team, you're hoping that somebody else in the world doesn't put together the best team, and everybody's focusing on the same problems around the world. All of us who visit every place, it's the same portfolio of stuff, right? You got to have people who understand the process of value creation. Now, here's a question for this group. If you went to a middle-level manager in your organizations and you asked them to define your innovation process, could they describe it in 1 or 2 minutes to you of what they do systematically to guarantee that your enterprise is going to be successful? How many of you could do that in your company and the middle-level managers would raise their hands? Well, I would say then there's a problem, because if innovation is the most important thing in the world today and your middle-level managers who are responsible for executing against it don't know that, then the chance of success, again, is just episodic when you get some extraordinary person or team that puts something together. That's been our experience all over the world. You need to have the best partners, the best VCs. As I said, just having VCs is not enough. If they really don't know what they're doing, you're basically wasting your time. You need to be in a complete innovation ecosystem. If you're outside of Silicon Valley, I've worked all over the world, it's really tough to get the talent and the, we have 3 or 4 places in America, Research Triangle Park, Austin, Boston, New York now, Silicon Valley, and a few other places, LA in some ways. But most parts of America are like you could be in the northern part of Sweden someplace, right? And starting a venture there is really, really hard. It's really hard. And I think we need to get serious about the fact that if you don't put all these pieces in place, the chance of success rapidly goes to zero. We can spend a lot of money and we can all tell our success stories, but how do you become systematic successfully in a world that's this competitive if your people don't know the fundamentals of innovation? And they don't have a process to guarantee that what they're going to produce. And you mentioned the culture of people. Yes, of course, the culture of most research labs has all these problems. We all know that. The question for a manager is, what are you going to do that guarantees that that goes away? Telling people that they have to behave differently doesn't do it. When the graduates come to SRI from MIT and Caltech and all these places, none of them have these skills. None of them. I do a workshop on innovation for every new employee. We put our people through workshop after workshop. Every part of SRI is focused on people standing up, giving their value propositions, being critiqued continuously to answer those fundamental questions that the best VCs answer every time. And even so, it's very hard. And we've dedicated the whole organization to this. And the truth is we've created tens of billions of dollars of economic value. Intuitive Surgical is one of our companies. That's a $27 billion company. Nuance is an $8 billion company. Siri on the iPhone, that put about $20, $30 billion into Apple, right? We go after these big opportunities. And even though we're as dedicated as we can be to 100% of this, even so, we only get a home run every 3, 4, 5 years. You've got to really take it seriously. And if there's one lesson, one message I want to give today is we are not taking the fundamentals of innovation seriously. And if we want America to thrive, we have to change the way we work. We have to change the way we work. We have to change the way we educate our kids so they've got the skills and the knowledge to be able to thrive in this world.
All right, we have just a few minutes left, so we're going to do the king for a day round through the whole panel. So we have these opportunities, we have these challenges, we've got a lot of the raw material to win here. We're trying to invent this new model. One wish, you're king for a day. Money, getting the right people around is no object. What is your wish? Mike Kluse.
Okay, I'm going to answer this quick, and then I'm going to leave because I got to catch an airplane. But
Yep.
Thank you. So my wish is, I really think we need to look at making it easier. I'm going to answer this from a national laboratory perspective. Making it easier for both universities and industry to work with the national laboratories. Great resource there, but there clearly are barriers. We need new mechanisms to enable that.
Great.
Okay, and I'm going to leave. Thank you.
Nice to meet you.
Kurt, no, tax policy not allowed, go.
I would teach everyone the fundamentals of innovation because if we had people in universities who knew what they were doing and teaching students the right way, and we had people in the national labs who were doing it and spreading the word, I think without changes to any of the other stuff, which I would also change, immigration policy and everything else, we'd start producing profoundly more value than we are today.
Peter.
Just a very local thought. I'd like to declare a free trade zone, actually within Argonne. Take particular targeted areas and do experiments and say, inside here the rules are different. I can have people with money come in, partner with us, work with businesses, use the assets which are actually at the lab, and to be able to do it in a seamless fashion, as I say, king for a day.
Very interesting.
And you know how hard that'll be.
Let's do it.
So here's a university chancellor perspective. I'd tear down the academic barriers between departments and colleges, try to create an environment where we hire the best scientists and hire the best engineers, but they're incented to work across the university and to work with the private sector and to do it in a way where the products are more clearly defined and clearly movable out into the industry.
Well, great. Well, one more step forward in solving this problem. We still have a lot of work to do, but I think as long as we're continuing to strive, to try new things, to evaluate them, to come together and figure out how we can put these things together, I'm confident we're going to continue to move in the right direction as a country, as labs, and as citizens to really push energy and manufacturing technologies forward. Let's give our panel a big round of applause.